It's day 28 of Advent. Day 28? There's only 24 days in Advent calendar. Or 25 if you get the really expensive ones. But day 28? What's going on here? Well, if you've been following along, first of all, thanks very much. We had a bit of a catastrophe on day 24. The camera, this wonderful setup here, decided not to play ball. All the footage came out blurry, but only after I recorded all of the footage and sat down to edit it at about 7:30 on Christmas Eve. Yeah, that was fun. Anyway, we're back, and the extra time has given me a bit more opportunity to build something a bit better. So Banana for Scale is here still, now in resplendent jumper. It is still Mark III. You can just see it underneath the jumper. Wonderful work there. Banana Pi Pico W. Some Christmas tree shaped thing that I got from Home Bargains for about £2 or £3. This comes with white LEDs, which are boring. So I've got the LEDs that come with Pimoroni's new Plasma 2040W, the wireless. Taken them off, stuck them on here, and they friction fit into little channels. And I've made up a little control script for it. So I'm going to show you what I'm on about. So, demo code. You remember a few days ago we had the Ampule module that I did a demo of. So where you can interact with CircuitPython to control an LED in that case. Well, I've really gone to town with that. I'm using Ampule now to listen for web requests that will control the NeoPixels. So these wonderful LEDs on this tree, it's looking for it. So I'll go very quickly. We've got import board, which we know is GPIO in CircuitPython. Import Wi-Fi connections, socket, we need that to sockets for connecting devices. Ampule, that wonderful module. Time, well, we have to give it a pause, don't we? We can't have it all happening at once. NeoPixel, we've used that previously for another CircuitPython project, controlling NeoPixel. Great fun. And from random import randint, random integers. Pixel pin is board GP29, and we have 50 NeoPixels in this chain. We create an object called pixels, and we say, okay, pixels is our NeoPixels connected to GPIO 29. There are 50 pixels, non-pixels is the object. Remember that, the variable. Brightness is 0.3. You can go higher, and if your power supply allows and your eyesight allows, you can try it, but be careful to get bright. And auto write false just means don't write the changes, we're going to say do it. This is some HTTP headers that we need to send in our requests. And here we are back to Ampule. So here we have our functions. Ampule root red. So if I send a crafted URL, which is the IP address followed by /red, this function called red will do this task. It creates an object called red which stores a tuple or tuple, I can never remember how to say that, which is 02550. These NeoPixels use GRB, green, red, blue. So to send red we have to have 0 for green, red 255, so fully on, and 0 for blue. We then fill all of the pixels red and then show it. That's the instruction to write the changes. And then we return the HTTP code 200, which is successful, along with the headers and a specially crafted one that says lights red. It's something that's going to pop up in a browser window or in something special I'll show you in a moment. Green is the same process. We just swap around the colours, so green is now 255, remember, GRB, and then send lights green when it's done. Last one of this one, blue, same process again. Something special now, we've got off. If you want to turn the LEDs off, the NeoPixels, well, we just say, okay, /off is the root. Create an object called off, which has zeros, so no light whatsoever. Fill the pixels with off, and then show it. And then return that status code. But the special one is disco. For every set of NeoPixels I've worked with, I've always written a disco little function. Something to play around with, have a bit of fun, but also learn how to control individual pixels. In this respect, we have ampule.root disco, and then we have the disco function, which uses a for loop 100 times to set the value of RGB, red, green, blue, to be something between 0 and 254, just an integer between 0 and 254. We're going to do the same for the pixel, P. And then we say, okay, print the value to the Python shell, and you can see down here I've been testing it. And then set pixels P, so a specific pixel, NeoPixel in the chain. That's been randomly chosen using randint to create P there. And then fill it with the colours RGB, taken from random integers here. Show it. Pause for 0.1 of a second, then go to the next pixel. Remember, it goes around 100 times. And then when it's finished, it will return the 200 successful code and say lights disco. At the end, we have all of the special stuff to connect to Wi-Fi. In this case, it goes to the secrets file, which is written on my Pico W here. Banana Pi Pico W, should say. Gets the details out of that and uses it to connect. It then tries to connect, and if it's successful, it will report the IP address and all the details that I need. If it doesn't, it says error connecting. And there's all the sockets and what have you to make those connections work. And then Ampule will just sit there and listen all the time for incoming connections. So this code is running right now. So let's go to how we're going to control it. Well, we've got the most basic way of doing it, which is in a browser. So there's a browser. You can see I've been testing it. We have the IP address of 192.168.0.5 / that's the root, remember, in Ampule, disco. So if I change that now to, let's say, red, you can see the LEDs are lit up. If I change that to blue, oh, and you get to see the return result there. If I say green, there's green. And if I say disco, if I spell it correctly, you see the lights slowly change colour. So we have basic control now of these NeoPixels over a Wi-Fi connection. Great! But typing in that URL every time is boring. What can make it more fun? Well, Node-RED. So right now I've got a Node-RED server running on a virtual machine on this PC. It's just really convenient to do so. And I've got some UI buttons. Now the dashboard I'm using, if I go to Manage Palette over here, is Node-RED Dashboard, this thing here. And it enables me to create buttons and interfaces in Node-RED in a web browser to control things. And I've used this a hell of a lot. It is awesome. Node-RED's great, but this dashboard makes it, yeah, chef's kiss. So I've got 5 buttons, nearly said 4. That's a Star Trek joke. We've got disco, red, green, blue, off. And all these buttons do is just send like an injection. You just send something to an HTTP request, which sends that scripted URL there, 192.168.0.5/disco. Through there, it then goes to our device, turns on the LEDs, and then returns a status code which I can then see in the UI. But now you're thinking, Les, I can just see flows here, there's no UI. Where's the UI? Well, here it is. So let's start off by sending red. So click on that. Red. We've got green. We've got blue. We've got off. We've got disco. And you'll see above the buttons is NeoPixel status. And that's returning the data that we get back from the Banana Pi Pico W that says, okay, the lights are disco, the lights are off. You can see it says lights disco. If I click on red now, it changes to lights red. So that, that delay the other day where everything went wrong has given me a bit of time to make something a bit more interesting for us all. Hopefully, if you like it. So yeah, there we go. Web controlled NeoPixels on a £3 plastic Christmas frame from Home Bargains, probably in the sale now so you can get it cheaper. £8 Banana Pi Pico W, they went down in price the other day. And of course, Banana for Scale Mark III, dressed in a Christmas jumper. And is it for Maker Advent, day 28. There's a weird one, isn't it? Anyway, I hope you had a nice Christmas, or happy holidays, however you celebrate it. I may see you in 2023 with more Maker Advent. See you later.